Hello everyone, so today we're going to be talking about the Pareto chart table knife defects. So we move on to the Pareto chart and we have the top 8 table knife defects. So first coming in we have the hit handle, which is at a rate of 239. Then we have the burn that comes in at 146. Then we have the scratch blades that comes in at 105, and then nicked and scratched 105, and then it goes down to seconds at coming in at 84, then hafting mark handle coming in at 64. Then we have the DD edge being the last one at 41. Then we move on to the 4 questions. And we also have the percentage line that goes across as well. And we move on to the questions. So the first question, I believe, was, are any of the categories related? So yes, the answer is yes. Several of the categories are connected because they come from the same part of each production process. For example, the scratches, stains, like I said, and improper polishing all relate to surface finishing or handling. Issues like bent tips or warping and dull blades from knives are tied to blade forming processes. And heat treatment comes into a big factor if the knives in the production process are treated right and are shaped in the way they need to be shaped. And like any cracks need to be, like each knife needs to be made precise, and they need to be well aware of the assembly or bonding problems. Grouping these defects this way helps us see where the process is breaking down and which improvements could fix more than one issue at a time. So the next question, to understand what we need to address first, we use the Pareto principle. This is what problems needed to be addressed and why they should be taken into action. So the idea that a few major problems cause most of the defects, in our case, scratches, stains, and bent tips are the biggest contributors to these knife defects. Tackling these first gives us the biggest improvement for the least amount of effort. These defects can also, if they're taken into precaution ahead of time, it can save us from having to make these adjustments in the long run. These defects also tend to be easier to correct because they relate to basic handling, polishing, or machine adjustments. Some cost Max will incur. So Max will face several categories, a lot of categories of quality costs. First are his internal failure costs like rework, scrap, extra labor, and downtime at work, all happening before the product leaves the factory or the place they are making the knives. Second I listed are the external failure costs, which happen if defects reach customers and lead to returns or warranty claims. And one I didn't include was appraisal costs, such as inspections and testings, to catch problems, like I said, early on, before they're able to happen in the future. And one I feel is most important is prevention costs, because prevention costs is in the name. If we try to prevent it from happening beforehand, then and we figure out ways to solve the problem, it's not going to continue to occur. And this includes training and equipment to stop defects from happening. So that's the way we could use those prevention costs. And all the 4 types of costs increase when the defect rate is high. So, yeah. what costs needs prevention cost Max should invest in and why. Um, to produce future quality costs, Max should focus on prevention. That's the most important areas in employee training, especially in polishing, handling, and inspection, because many defects come from small areas in these steps. Max should also invest in equipment upgrades and preventative maintenance for grinding, polishing, and heat treating machines. These improvements will really help the dull blades, the warping of the knives, and uh, other process related defects relating to the knives. But that concludes my answers to these questions, and I'm gonna leave it at that.